Alright, Subpart D track structure. 213.101. Subpart prescribed the minimum requirements for the ballast cross ties track assembly fitting within the physical condition of the rail. 213.103 ballast in general, unless otherwise strictly supported with all the track is supported material which will 103.1 transmit the distributed load of the track railroad rolling equipment to the subgrade restraining the track laterally longitudinally vertically until the dynamic loads imposed on the railroad rolling equipment thermal stress imposed on the rail. Guidance ballast must consist of the crush slag, crushed stone, screen, gravel, the pit run, gravel, the chat, cinders, scoria, pumice, sand, mine waste, or other native material is an integral part of the track structure. Ballast, regardless of the material, must satisfy the requirements of the state of the track safety standards. 103C, provided with adequate drainage for the track. 103D, maintain proper track cross level surface alignment. The guidance inspector should consider overall condition of the track with the siding valve and ballast. Ballast conditions are going to be subject to nature. Inspector should also look to other indicators such as the geometry condition. For example, the foul ballast violation may appropriate if the track has poor drainage in the geometry condition or a series of foul ballast location of geometry conditions. The term geometry condition used elsewhere in the manual means track of the strip of the gauge alignment and regularity due that does not exceed the allowable threshold for the design track class. It exists due to the reduced non-existent capability of one or more of the track structural components to hold the track in preferred geometrical position. 213.109 cross ties. 109A cross ties shall be made of material of the rail securely fastened. 109B each of the 39 foot the segment of the track shall have a sufficient number of cross ties which combination provided with effective support that will hold the gauge with the limits prescribed in 213.53B, main surface with the limits prescribed in 213.63, and maintain alignment with the limits prescribed in 213.55. The minimum number and type of the cross ties specified with paragraph B4 of the section described in paragraph C and D of the applicable of this section effectively distributed support entire segment, and at least one of the non-defective cross ties of the type specified with the paragraph C and D of this section located with the joint location specified in paragraph E of this section, and the minimum number of the cross ties indicated with the following table. Class 1, tangent tracks curve the number 2 degrees, five ties. Turnouts curved to over 2 degrees, 6 ties. Class 2 tangents curved number 2 degrees, 8 ties. Turnouts curved to over track over 2 degrees, 9 degrees. Class 3 8 ties for under the track tangent curves of 2 degrees, and 10 ties for turnouts can curve track over 2 degrees. Class 4 and 5 12 ties for a tangent turn curve of 2 degrees, and 14 turnout curved over 2 degrees. Guidance: the track safety standards determine the adequacy of the cross ties supported, including the functional requirement to maintain the track geometry with limits specified in subpart C. If the failure of the cross ties meet the three above the criteria that constitute the deviation of the track safety standards, effective distribution has not been denied, but it must not be interpreted with the inspector assignment in synonymously equally spaced language of the intent of the draft situation where all non-defective ties exist in a group of the short area of the wheel of 39 feet long with the track question. The evidence of the cross ties are not effectively distributed include the primary indication of the actual deviation of the geometry condition. Note the criterion exists for the maximum distance between the non-defective ties. The measurement should not be used to describe the tie defect. If such description appropriate should be used, be in terms of the number of the consecutive defects and ties in a group. When the citing of the 213 defective code 0109B2, the cross tie is not defective distributed to support the 39-foot segment of the track. The inspector must show evidence of one or more of the geometry condition of the statute 213.109B1. Several factors may be documented defects as being cited. The factors include but are not limited to geometry condition, class curve, class of track, curvature, track density, annual tonnage, rate, well in condition, or other component of the track. Where determination compliance with the section, inspectors may determine the cross ties meet the requirements of effectiveness is defined with the above to make the geometry measurements to verify that each 39-foot segment has a sufficient number of ties, effective ties meeting the geometry required, non-effective ties of the track class described in paragraph B4, proper placement of non-defective ties described in paragraph B4, and the position required in paragraph E to support the joints. The majority of the cross ties throughout the nation are wood, but however they are a variety of the alternate design cross ties made with the material of the composite steel with the concrete. The type of the cross ties being common the most commonly throughout the industry because of the increased use of the alternate design cross ties associated with the resolid type of the rail fasteners. Inspectors should be more rigorously considered the rail cross tie interface. Also see statute 213.127 rail fastening. Cross ties other than concrete continue with the satisfy the requirements set forth in paragraph B4 of the section shall not be broken, split, otherwise impaired with the extent of the cross tie will allow the barrels to work through. It will not hold the spikes the rail fastener set. So deteriorated the tie plate base of the rail car move laterally more than 1/2 inch of the relatively the cross tie cut in the tie plate through the more than 40% of the tie thickness. Guidance. Paragraph C with maintains mainly apply for the wooden ties, although it does not explicitly exclude the composite and steel ties. When cross ties exhibit one or more of the conditions described in the four criteria of the evaluation, Statute 213-109C1 through 4 may be considered non-effective itself, although the determination might also reflect the defective condition can be recorded under Statute 213 Defective Code 0109A, 0109B2, 0109B3. If the track geometry measures the failed measurement of the requirement subpart Z, there are an efficient number of effective cross ties, but the geometry cross ties could be cited with defects. Geometry measures exceed the allowable tolerance, but determined it cannot be made with the cross tie of the cause of the appropriate side of the defective geometry. The FRA inspectors must use the PTLF described in Statute 231-110, the purpose of measuring the located gaze to determine the effective distribution of the cross ties. Refer to the appendix D PTLF instruction for the non-GRMS territory under the Statute 230-53. 109D concrete cross ties counted to satisfy the requirements set forth in paragraph B4, but this section shall not be broken through the deteriorated extent of the pre-stressing materials visible, deteriorated or broken off at the vicinity of the shoulder insert with the fasten assembly can either pull or laterally more than 3/8 of an inch relative to the cross tie, deteriorated such that the base of either the rail can move laterally more than 3/8 of an inch relatively to the cross tie, and the curves of 2 degrees or greater can move laterally more than 1/2 inch relatively on the cross ties, curves less than 2 degrees. Deteriorated, abraded at any point under the rail seat depth of 1/2 inch or more. Deteriorated such with the cross ties fastening and anchoring system, including the rail anchor C. Section 213-127B is unable to maintain longitudinal rail restraint, maintain rail hold down, and maintain gauge down and efficiency fast holder and tow load. C configured with less than 2 fasteners on the same rail, except provided with the Statute 213-127, the guidance of the cross ties evaluated individually definition and functional criteria set forth in the guidance of cross tie effectiveness, natural subject with required good of the judgment, application for interpretation with the stand design to the durability of the cross tie demonstrated the 39-foot track segment, maintain safe track geometry, structural support when imposed with the wheels and the minimum deviation key of the track segment, lateral longitude, vertical support with the strong track modules, which is measured for the vertical stiffness of the rail foundation, continued superstructure, including the rails, cross ties, fasteners, and high quality ballast characteristics to transmit the both dynamic thermal loads to the subgrade, as also important proper drainage and free of the presence of excess of the moisture inherent with the crucial fixture and provided with the added substructure. Section 213-109 continues the specific performance of the requirements of the FRA class 1 through 5 of the track addressed with the unique characteristics of the fastener, reliability, concrete cross tie, the reported stability. The inspector should be aware of the 3 modes of the concrete cross tie: failure, support, stability, electrical isolation, comprehensive strength of the concrete with the amount of the pre-stress of the section composition provided with the strength stiffness necessary to support expected wheel load, the balance between the effective excessive stiffness that can be lead with the high stress at the bottom of the cross tie at the rail seat. Conversely, a loss of stiffness caused by an increasing axle load can lead to excessive rail defection damage to the valve subgrade. Inspectors should be aware the failure's modes are not isolated with the cross-tie defect. The combination complaint by the irregular track of the rail geometry, reported drainage, insulation, ballast depth, subgrade, soil conditions may contribute to failure to root casual factors. Paragraph D delineates the requirements related with the concrete ties. Modern concrete ties are designed to accept the stress imposed with the regular railhead geometry loss. The excessive wheel loading caused by the wheel irregularities outrun the excessive unbalance of the track geometry defect. Section 213-109 considers the worst combination of the condition which can cause an excessive impact with the eccentric load. The stressing would increase the failure rate for the other measuring concerning load of the toe bed and longitudinal lateral resistance in addition with an improper rail cant. Paragraph D1 states that concrete ties can, with the fulfill the requirements of paragraph B4, must not be broken through the deteriorated extent with the pre-stressing materials visible. Cross ties may not be so deteriorated that the pre-stressing material has been visibly separated from the visible loss bound with the concrete, resulting either with the cross tie particle breakup of the crack is exposed from the pre-stressing material down due to spalls and chips with insignificant broken out areas exposing pre-stressed material. Currently, metal reinforcement bars are used in pre-stressing material and concrete cross ties. The FRA using the term pre-stressing material is in lieu of the metal reinforcing bars to allow the future of technology and advances. The distinction between the phrase broken through and the deteriorated extent with the pre-stressing material is visible. The concrete cross ties are manufactured in two basic designs, twin block and mono block. The twin block cross ties is designed two sections over the concrete exposed with the metal rod. The mono block cross tie is similar dimension, but the timber wood cross tie contains the pre-stressed metal strands embedded with the concrete. The pre-stressing metal material concrete is preserved at the end of the cross tie with proper tension position. Pre-stressed, the reinforced concrete cross ties are made with the stressing of the reinforced material in the mold, pouring the concrete cement concrete over the reinforcement material in the mold. After the concrete curve, the tension of the reinforcement material is released, and the end of the reinforcement material in the trimmed and inappropriate for the use of the pre-stressing material remains tension against the concrete with very strong comprehension. This allows the pre-stressed concrete to withstand both the compressive and tensile loads. If the concrete spall of the pre-stressing material is otherwise allowed to come out of the contact with the contact pre-stressing material is no longer in the tension. The concrete cross ties full strength stiffness is lost with the pre-stress force reduced with the corrosion. Concrete deterioration poor bond with the concrete due to the improper manufacturing of the pre-stressing material may be corrode and insufficient concrete or insufficient concrete covered or concrete cracking allows the intrusion of moisture and oxygen, which happens as once a pre-stressed concrete cross tie is no longer withstand tensile load, it will vary rapidly in surface. Our pre-stressing material is often exposed with the concrete cross tie as a crack, but it also can be exposed with the side of the tie. With pre-stressing material may be exposed with the side of the cross tie. Pre-stressing material is no longer tension. Pre-stressing concrete has no longer withstand the tensile load. Therefore, concrete cross ties being structurally failed. This does not apply to the reinforcement material less visible at the end of the cross tie during the manufacturing process. The comprehensive strength of the concrete material, the amount of the pre-stress applied with the manufacturing process, provided with the strength and stiffness necessary, adequate support with the distribution wheel load to the subgrade, the pre-stressing material encased with the concrete with the cross tie together with the provided the tensile strength, however, the significant cracking, discernible deterioration exposed with the reinforced strength of the water oxygen produced the loss of the pre-stress force of corrosion, concrete deterioration, poor bonding, loss of the pre-stress force rendered with the cross tie, susceptibility of structure failure as in consequence stored ability failure relating to track geometry noncompliance. Cross ties transversely broken between the rail sheet shown with the sign with the further deterioration, loss of the tension, pre-stressing material open to level, the exposure of the metal bands. Metal strands constitute failure. The means for these cannot be complete separation of the concrete material making up the cross tie. Cross ties must not be deteriorated that the pre-stressing material has visibly separated with the visual loss of the bond with the concrete, resulting either with the cross tie partial breakup or in cracks with exposing pre-stressing material due to the small chip. The significant broken out areas are exposed with the pre-stressed material. Cross failure exhibited with three distinct ways. Stress indicated with the breaks and cracks, mechanical abrasions, chemical decomposition. The condition of the small and large decay is compromised with the cross tie's ability to maintain proper gauge alignment and track surface. Walking inspection would demonstrate the clearly visible spalls, chips, and cracks of similar breaks. However, the compression of the pre-stressed concrete cross ties may close the cracks, the curve making them difficult to observe, even though the closed cracks probably weaken the cross ties. Breaks and cracks are divided in three general conditions: longitudinal cracks, center cracks, and rail seat cracks. The longitudinal cracks are horizontal with the cross tie extended with the parallel ends of length. They intend with the higher impacts on both sides of the rail, bearing insert for the cross center cracks are vertical cracks extending transversely across the cross tie. The cracks are usually a result of the heavy high negative bending of the movement, usually center bound with the operating with the cross tie, but they extending with the bottom of the generally conditioned progressive adjacent cross ties may defect. Rail seat cracks are vertical cracks. They are not easily visible. They usually extend with the bottom of the cross tie, one on both side of the cross tie, and are often hard to detect. It is possible the cross tie broken through due to location of the breakup of the pre-stressing material may not be visible. Cross string generally does not fail unless the crack extends for the top layer of the pre-stressing material. Though one crack extends beyond the top of the layer, usually loss of the pre-stressing concrete bond strength. Paragraph D2 makes it clear that the cross ties counted with the fulfilled requirements. Paragraph B4 with the section must be deteriorated, broken off the vicinity of the shoulder. Insert of the fastener assembly can either be pulled out with the move laterally more than 3/8 of an inch and relatively cross tie as these conditions weaken the fastener integrity. Paragraph D3 provides the cross tie counted with the full final limit requirements. B4 must not be deteriorated such to the base that either the rail can be laterally moved with the 3/8 of an inch relatively cross on the curve of 2 degrees for the greater, and move laterally more than 1/2 inch relative to the cross or tangent curve of the less than 2 degrees. This section allows the combination of all the rail movement inward, outward, and the dimensions specified, but it's not separate with each of the rail fasteners assembly of the work system capable of providing electrical insulation, adequate in resistance, lateral displacement, undesired winding, rail canting, rail rail rollover, abrasive, excessive compressive stress, in accordance with policy and procedure. Inspectors are encouraged to use the assigned portable track loading fixture, or PTLF, assessing the amount of lateral rail performance movement where applicable. All right, paragraph D4 requires the cross ties counted with the full requirements of paragraph B4 for the section deteriorated braided at any point of under the rail seat. The depth of 1/2 inch or more. The measurement of 1/2 inch includes the depth of the loft of the rapid pad, rail pad. The importance of having the pad material in place from the sufficient hysteresis is resilience, elasticity, dampening height, impact of loading of the recovering the two is paramount to the control. Rail seat cracks caused by the rail surface defects, wheel flats, outround wheels. Additional concrete costs may be caused to providing adequate rail longitudinal restraint. The effect of rail creepage, thermal, including the force of the truss. Rail creepage is attractive effort, pulling force exerted by the locomotive of the car wheels, thermally introduced, including force of stress, longitudinal expansion with the contraction of the rail, creating either the compressive tensile force, the rail temperature increasing, decreasing rapidly, respectively. The loss of the pad may cause the loss of the tow load force, which may decrease the longitudinal restraint, such as the following nature: noteworthy, inward, and outward rail cant angle conventions interchange among the geometry measure system. The upright geometry cars record inward can be positive and outward is negative. Outward can't, inward can't, positive, outward can't, negative. Alright, this shows the top of the rail plane, the rail can't, outward, and negative angle. Our paragraph D5 requires the cross tie of the full requirements of paragraph B4 of the section must not be deteriorated such that the cross tie fastening anchor system, including the rail anchors, is unable to maintain the logical restraint, maintain the rail hold down, the maintain the gauge due to the inches of fastener and tow load. Inspectors evaluate the cross tie individual definitional functional criteria of the complaint with the cross tie is demonstrated with the 39-foot track segment, maintains safety of the track geometry and structural support for the imposed wheel loads. In addition, with the ballast anchor, the bearing, the ends to the side of the cross ties, control longitudinal rail movement. A certain type of the fasteners also acted as a control rail of the movement exceeding the downward clamping the force tow load on the upper rail base. Part of the complexity of the cross tie assessment of the fastener component with both the cross tie and the fasteners act as the same system to deliver the expected performance effect. The non-compliant with the cross tie, the defective fastener assembly, and proper maintenance with the rail position supported in the rail seat contributes to excessive lateral gauge winding. Rail can't roll over in longitudinal rail movement because of the loss of the tow load. Fasteners assembly anchor system allows a certain amount of the rail movement through the cross tie effect of the relieve the rail creepage attractive effort thermal force build up. However, because of the unsure restraint build up caused by the rail creep, the longitudinal expansion of the contraction of the rail creates the compressive tensile force with respect to the longitudinal repairment of longitudinal rail movement is uncontrolled and may distribute the track structure, causing misalignment with compression, pulled apart tensile conditions to the catastrophic failure. Specific longitudinal performance metrics would be undesirable. The restraint can certain factors assembly design capabilities to control longitudinal rail movement. Therefore, inspectors must be used with good judgment in determining faster assembly cross tie effectiveness. Paragraph D6 makes a clear cross tie count with the full requirements of the paragraph B4 of the section must not be confined with the less of the two fasteners of the same rail expected to provide in statute 213-127C, which includes the requirements specific to the fasteners used in conjunction with the concrete cross ties. With the non-concrete ties, one of the safety requirements of the effective concrete tie is the ability to hold fasteners. 19E Class 1 and 2 tracks shall have the cross tie when the center line is within 24 inches of each of the rail joint end of the location. Class 3 and 4 shall have either one cross tie with the center line is in 18 inches of each of the rail joint location, two cross ties with the center line within 24 inches of either side of the rail location. The relatively position of the cross ties is described in the following three diagrams. Each rail can joint with the Class 1, 2, and Class 1 and 2 shall be supported with at least one cross tie specified with the paragraph C and D of the section, whose center is within 48 inches. Center line is within 48 inches. Figure 1 shown. Figure 1 showed the defectiveness of 48 to center cross ties, 24 inches, Class 1. Each rail joint, Class 1 and 2, each rail joint with 3 and 4 tracks shall be supported with either the one cross tie specified in the C and D of the section center line with 36 inches shown in Figure 2. Figure show the 36 inches the difference between the cross ties and an 18-inch split down the middle. Two cross ties on each of the rail joint with center lines of 24 inches of the rail joint shown in Figure 3. Class 3 through 5 have a 48-inch span from center to center to the cross tie and 24 inches from the center. Guns. A non-defective joint must be found with the prescribed distance for the center of line with the joint measure of the rail in class 3 and 5 with the joint to a tie placement to satisfy either one configuration with the two tie configuration. Clarify the measurement of the description short P for the rail only when should then inserted between the rail ends but then incorporated with the joint bar assembly measuring the bar center line at C, such as 213, 121D rail joints. Right. Once again, that is defective one class at 48 inches, 24 inches apart. Class 3 through 5, 8 inches, 18 inches, 36 inches, and class 3 through 4, 24 inches, 48 inches. Same as class 3 and 5, adding class 1 and 2, and then there's class 3 and 5 defective. Show the defective 36 inches from the 18 inches. Where non-symmetrical bars exist, 5-hole heel block bars with 5-hole compromising bars measured with the design point with the rail end of the normally above the 109.5 and 109F for the track constructed with the cross ties such as slab track connected directly with the bridge structural components tracking over the surfacing pit access with the track structure shall meet the requirements of paragraph B1 of this section. Guns. The paragraph addresses the track constructed with the cross-tie bridge timber to the sides of the concrete slab of the track with the running rail secured with the fixation of another substructural member. In general, discrepancy may arrive with the evaluation cross-tie in addition to the decision based on the inspector maintenance experience of various divided among the inspectors. Inspectors shall evaluate the tie condition solely on the basis of definition provided in this section. Each cross-tie may be evaluated individually by this criteria. As all provision for the track safety standard, the inspector must use the judgment and discretion for the application of cross-tie standard. They should be used with the description of the condition for the risk of the safety operation of train sets shall not be allowed to apply the double fault case. Gauge rods are not as effective substitute for the proper cross-tie of the rail fastener system. The gauge rods cannot be subjected to the sudden failure. They provide no vertical rail support and they provide no resistance to rail rollover forces. However, the gauge rod may be installed when they are used secondary means of support maintaining gauge. The gauge rods are used for the obvious condition for the cross-tie fastening system in the immediate vicinity incapable of maintaining adequate gauge. The inspector should consider citing in the cross-tie and fastener defect. Alright, certain cross ties may not be able to hold the spikes of rail fastener in present conditions, and the case for the impossible for the bringing cross tie in compliance with either the plugging or respiking additional railing, holding, plating, holding spikes, or both. Where conditions are closer than the rail fastener issue, the EG sounds and ties and track are not fastened to the rails. Inspector should reference under the statute 213-127. 213-110 gauge resistant measurement system. Track owner may elect to implement the gauge restraint measurement system or GRMS, supplemented use of the portable track loading fixture PTLF to determine the compliance of the cross tie fastener requirements specified in statute 213-109, 213-127, provided the track owner notified the appropriate FRA regional office at least 30 days prior to the designation of any line segment within which the gauge restraint measurement system technology will be implemented. The track owner notified the appropriate FRA regional office within 10 days prior to the removal of any line segment of the gauge restraint measurement system designation. The paragraph provides the implementation of the gauge restraint measurement system supplemented with the portable track loading fixture to determine the compliance with the cross-tie rail fastener requirements specified in 213-109 and 213-127. The track owner selecting and implementing technology must provide the appropriate FRA regional office with notification specifically identifies line segments of the gauge resistant restraint measurement system. It will be used the appropriate FRA office for the headquarters of location of the FRA region where the gauge restraint measurement system designated line segment is located. The notification must be provided with the FRA at least 30 days prior to the destination. Any line segment will be subject to requirements for this section, even though the notification requirement is satisfied with the gauge restraint measurement system vehicle is determined to meet the minimum design requirements. The actual triggering event that must place the line segment of the gauge resistant measurement system requirement the initial track survey of the gauge resistant measurement system vehicle. The track owners must also provide the FRA with at least 10 days notice prior to the removal of the line segment of the gauge from the gauge resistant measurement system designation. The requirements that is provided with the FRA advance the notice of the criteria change of the inspection cross ties fasteners in place for the some control over the random removal of line segment of the gauge resistant measurement system designation. 110B. The initial notification under paragraph A1 of the section shall include identification line segment timetable designation milepost class of the track, identifying criteria of the most recent record of 1 million gross tons of the track per year over the identified segment. Or the paragraph specifies the information track owner should include the notification of FRA of the line segment after the gauge resistant measurement system inspection information must include the minimum of the segmented timetable designation milepost track class, the minimum million gross ton per traffic per year of the another identifying characteristic of the segment. For reasons of safety, the gauge resistant measurement system vehicles have split axle with the retracted position with the testing with the special track work with such determinants as grade rails, rail crossing, diamond expanding joints, the rail lifting rail assembly where certain track that was not part of the designation notification shall identify specify what these locations are and whether the distance approaching leaving these locations are also excluded from the gauge resistant measurement system designation. Locations excluding the gauge resistant measurement system designation will subject for the requirements of Statute 213-109 and 213-127. Or 110C1, the track owner should also provide the effort sufficient technical data of establishing with the following minimum design requirement of the gauge resistant measurement system. The gauge resistance shall be measured between the heads of the rail in an interval not exceeding 16 inches under the applied vertical load not less than 10 KIPs per rail, and under the applied lateral load with the provided lateral vertical load ratio of 1.5 to 1.2, and load severity greater than 3 KIPs, less than 8 KIPs per rail. Guidance. The paragraph describes the minimum design requirement of the gauge resistant measurement system vehicle. Track owner must submit the effort sufficient technical data with the agency can establish whether the track owner compliant with these design requirements. The paragraph requires the gauge must be measured between the heads of the rail in the interval not exceeding 16 inches. The paragraph provides the decent flexibility establishing acceptable range of the lateral vertical load ratio with the result of lateral load severity in both of which that can be satisfied various load configuration provided the applied vertical load is not less than 10 KIPs per rail. The rule provide with the during design flexibility establishing acceptable range of various loading requirements. The range considerable absolute loading configuration with a small fall outside of the prescribed range with the not considerable acceptable some loading configuration may develop high with the lateral vertical load ratio. Therefore, the lubrication of the gauge face, the railhead of the split axle may be required to produce the conveniency of friction to prevent wheel climb. Footnote 5 in this section causes the operation of the L and V load actual vertical load and vertical loads, actual lateral load implied with vertical load ratios exceeding 0.8 to protect against the risk wheel climb and test wheel set. The footnote is identical to footnote 10, which applies to the Statute 213-333 automated vehicle-based inspection system to ensure the conformity between the section subpart G with the counterpart. 110D load severity is defined in this formula: S equals L minus CV. Load severity defines lateral load applied with the fastener system. KIPs equals actual lateral load applied with the KIPs minus coefficient of friction between the rail tie, which is assigned the normal value of 0.4 times the actual vertical load pounds. Static vertical wheel load. Vertical load is not measured. Guidance. This paragraph describes the formula calculation load severity required in 110C2 3. The coefficient of friction of the rail tie, the interface with the can change with the load severity level. Applied actual lateral and vertical loads are given, however, the impractical to determine the actual coefficient of friction with which vary from place to place in the gauge resistant measurement system territory. Nominal value 0.4 can also be used. 110E, the measured gauge value should be converted with the project load gauge of the 24 are as follows. The project load gauge 24 is equal to the unloaded track measured with a gauge resistant measurement system vehicle at a point not less than 10 feet from any lateral vertical load application times the exploration factor they use to convert the measured load gauge to the expected load of the gauge under the 24 KIP lateral load 33 KIP vertical load. Times the unloaded track gauge measurement of the gauge resistant measurement system vehicle to point no more than 12 inches from the lateral load application, minus the unloaded track gauge measurement gauge resistant measurement system vehicle not less than 10 feet and any lateral vertical load application. For all track, note that the A factor should exclude the value of 3.184 under the value loading configuration, where L is actually the lateral load that applies to KIP. So V is actual vertical load with the KIP static vehicle wear load and vertical load is not measured. Alright, you have A, your exploration factor of the converted with the measured load gauge with expected load under the 244K lateral and 33.3 vertical load. 13.5153 times the actual lateral load applied times 0.2 minus 2.258 times V minus 0.9 times L times 0.25 times L V squared. The paragraph describes the formula calculation projected load gauge of the 24 PLG2 24 projected load gauge 24. The formula provides the method of normalizing projected load gauge regardless of the actual lateral load applied to the different gauge resistant measurement system. Accurate measurements unloaded with the gauge restraint measurement system load gauge. The lateral load applied with the critical importance becomes the measurement of the calculation projected load gauge of the 24 value that constitutes the direct measurement of the track strength. To minimize the influence of the adjacent load, the unloaded track gauge or UTG must be measured with a gauge resistant measurement system vehicle at a point no less than 10 feet of the lateral vertical load application of the load track gauge at the point of no more than 12 inches from the lateral load application. The gauge GPW without minus LTG minus GPW equals LTG minus UTG times distributed times 8.26 L minus 0.285 minus V. The paragraphs prescribe the form of the calculation of the gauge widening projection. The gauge widening projection intended with the compensate with the wheel of the testing vehicle with using the gauge widening projection support with the research documented with the reported development of gauge widening projection parameter, the deploying gauge restraint measurement system FRA ORD 06 1-13 October 2013 when available at the FRA website. Making criteria for the section consistent with the statute 213.333 subpart G with the rule make it easy for the track owner railroad to comply with the gauge resistant measurement system requirements regardless of the class of track. Or 110G, the gauge resistant measurement system vehicle shall comply with the producing output reports provided with the trace on a constant distance scale on all parameters specified in paragraph L of the section. 110H, the gauge resistant measurement system shall be capable of providing exemption of the report containing a systematic listing of all exemptions of magnitude, location, and to all the parameters specified in paragraph L of this section. 110I, the exemption reports required for the section shall provide an appropriate person designated fully qualified under statute 213.7 prior to the next inspection required in the 213.233. Paragraph G, H, and I require the gauge resistant measurement system vehicles be capable of producing strip charts with all the parameters specified in paragraph 1 of the section printed with the exemption of the report listing magnitude, location exemption from the parameters exemption report listing provided with the appropriate person designated the full qualified in statute 213.7 prior to the next inspection required in the statute 213.233 of the track safety standards. Since the premise is bound the gauge resistant measurement system technology to identify the error of the weak with the gauge restraint, they either need immediately action. Attention must be continually monitored until the next year. Gauge resistant measurement system inspection exemption report listing must be retained available for review for the statute 213.7. The inspection personnel. The FRA inspection will obtain and have the access to the exemption report with conducting regular compliance with the exemption of the over the gauge resistant measurement design line segments. Or at 110J, the track owner shall institute the necessary procedure for maintaining the integrity of the data collected with the gauge resistant measurement system, the portable track load fixture system. At a minimum, the track owner shall maintain the maximum available Federal Railroad Administration documentation calibration for each of the gauge resistant measurement system vehicles, which at a minimum specify the daily instrument verification procedure to ensure the correlation between the measurement made on the ground and these recorded with the instrument respective load and unloaded gauge parameters. Maintain the portable track load fixture used to determine compliance with requirements of the section, such as 4,000 pound reading and accurate to 5% of the reading. Guidance. The paragraph requires the track owner to institute procedures to ensure the integrity of the data collected with the gauge resistant measurement system and the portable track loading fixture system. Track owners must maintain documentation calibration procedure on the gauge resistant measurement system vehicle, make them available upon the request of the FRA representative of the daily instrument verification procedures required for the ensure the measurement of the loading and unloading gauge required for the instrument correlate with the accurate actual field measurement. Track owners must develop and implement the necessity of the portable track loading from the fixture and inspection maintenance procedure so that the 4,000 pound reading accurate with a plus to minus 5%. Or at 110K, track owner should provide with the training of the gauge resistant management system technology personally designed with the valid qualified in statute 213.7 of the territories are subject to the requirements of the section. Training program should be made available to the Federal Railroad Administration upon the request of minimum of the training program should address the basic gauge resistant measurement system procedures, interpretation, handling exemption reports generated with the gauge resistant measurement system vehicle, locating, verifying defects in the field, the remedial action requirements used in calibration, portable track loading fixture, and recording requirements. This paragraph recognizes the need for the person designated fully qualified under Statute 213 with the territory subject to requirements of the section to receive the training and implementation gauge resistant measurement technology. The track owner therefore required to develop the formal gauge resistant measurement system training program that must provide available to the FRA upon request. Training effective to the employee of the another triggering event that must be satisfied prior to the line segment that is being designated with the gauge resistant measurement system territory under the section. The Training program must provide with a detailed instruction of specific areas identified in the paragraph. Particular training must be derived for the gauge resistant measurement system, operational procedure, interpretation, handling, exemption reports, how to locate and verify the gauge resistant measurement system, identifying the remedial action requirements initiated, and when defects are verified, how to use the calibrated portable track load fixture, the recording requirements associated with the implementation gauge resistant measurement technology. The requirement of the gauge-resistant measurement technology applied with the fully qualified 213 step with the personally under paragraph A and B are going to be subject with the personal subject to the requirements of this section. This is not to say the fully qualified 213 7A personal need is training welder foreman, production gang foreman, etc. And it is also not necessary for all fully qualified 213 7A who receive the gauge-resistant measurement training to be issued portable track load fixture. For the circumstance arrived with the need for the portable track load fixtures, they should be accessed one and be trained in how to interpret the results. The track owner must also take into consideration relief position new qualified personnel transportation and transfer of non-gauge resistant measurement territory into the gauge resistant measurement territory will be subject to the gauge resistant measurement territory requirements of this. Personnel must provide with sufficient instruction training being able to demonstrate the track owner then know the understanding of the requirements of this section. 110.11. The gauge-resistant measurement record lateral restraint shall identify the two exemption levels. The minimum of the track owner shall initiate the required remedial action at each exemption level that's defined in the following table. UTG is values exceed 58 inches, LTG 58 inches, PLG 59 inches, GPW 1 inch. First level exemption remedial action 1. Immediately protect the exemption location from the 10 miles an hour speed restriction verification. Verify the location. Restore the lateral restraint maintaining compliance with the portable track load fixture criteria described in paragraph M of this section. Maintain compliance with statute 213.53b as measured with the portable track load fixture. Alright, gauge measure second level exemption LTG with the 57 and 3/4 inch class 4 and 5 the track. And PLG 58 inches, GPW 0.75 inches, limiting operating speed no more than maximum allowable under statute 213.9 with the class 3 track verification location, maintain compliance with the portable track loading fixture described in paragraph M of the section, maintain compliance with the statute 213.3b of the measured portable track load fixture. Or the VTI final rule of the corrective of the table renumbered the remedial action specified in the second level exemption. Remedial action has been designated 1 or 2 or 3 of the remedial action required columns consistent with the remedial action specified first level exemption. Paragraph specified the parameters and thresholds levels required to report the record lateral restraint following the inspection of the gauge resistant measurement system. The regulations require 2 levels exemption being reported the gauge resistant measurement system. The special remedial actions are required for each of the level, identifying the remedial action required column for first level exemption required immediately protected with the 10 miles an hour speed restriction until verification correcting action can be instituted. Second level exemption must be monitored and maintain portable track loading fixture criteria until lined in paragraph M of this section. Prior knowledge criteria satisfied with those locations identified the first and second level exemption record lateral restraint generated from following gauge resistant measurement system and inspection of the field inspection conducted with the gauge resistant measurement system inspection revealed the exemption load that does not comply with either the track strength measurement requirement of the gauge requirement that is identified with the paragraph M of the section. Inspector should consider recommending civil penalty for locations that do not comply with the requirements of the paragraph M have not been identified with the record lateral restraint with each of the first and second level exemption. The inspector shall exercise the discretion to determine whether or not civil penalty shall be recommended. Footnote 2. The table recognizes the typical good track will increase the total gauge of the mesh with 1/4 inch due to the outward roll rotation of the gauge restraint measurement system loading condition. Accordingly, in Class 2 and Class 3 tanks, the gauge track, the gauge resistant measurement system load track, the value of the measuring increase with 1/4 inch to the maximum 58 inches. The gauge resistant measurement system load track, the values that exceed 58 inches must always be considered first level exemption. This 1/4 inch increase the gauge will apply to only the gauge resistant measurement system load gauge. It does not apply to the portable track load fixture gauge resistant or to the measurement made with the traditional methods. 110M between the gauge resistant measurement inspection of the portable track loading fixture may be used with additional and analytical tool assisting fully qualified statute 213.7 individuals determining compliance with the cross-size fastener requirements of statute 213.109, 213.127. The portable track loading fixture used with additional and analytical tool full requirements paragraph L shall be used with the subject following criteria. In any location of the track of the portable track loading fixture is applied, the location will be deemed in compliance with the cross-size fastener requirements specified in the statute 213.109, 213.127, provided the total gauge widening of the location does not exceed 5/8 of an inch of increase in the applied force of 0 to 4,000 pounds, and the gauge of the track under 4,000 pounds applied force does not exceed the allowable gauge prescribed in Statute 213.53b of the class of track. 2. Gauge widening in excess of 5/8 of an inch shall constitute the deviation from Class 1 standard. The person designated with fully qualified 213.17 retains discretionary authority for the prescribed additional remedial action for those locations comply with requirements of paragraph M1 and 2 of this section. Functional portable track load fixtures that are not available for fully qualified personnel designed under the statute 213.7 of the criteria determined cross tire fastener for compliance shall be based solely on the requirements of statute 213.109, 213.127. If the portable track loading fixture becomes non-functional or missing, the track owner will replace and repair it before the next inspection under the statute 213.233. When vertical loading of the track is necessary for the contact lateral restraint with the component of the portable track loading fixture test will be considered valid until the contact with the components is restored until under static load conditions. Guidance. When the remedial action table of the paragraph L requires the use of the portable track loading fixture to measure the compliance with the lateral restraint with the gauge requirements and identify the exemption with the location gauge resistant measurement territory. Paragraph M provide the use of the portable load track fixture with additional analytical tool fully qualified in statute 213.17 the individual location of the gauge resistant measurement territory. The paragraph M also describes the measurement of the portable track loading fixture measuring the gauge resistant measurement system territory with the being used additional analytical tool being used to meet remedial action requirements set forth in paragraph L, compliance with the statute 213.109 and 213.127, demonstrating the portable track load fixture that applied with 1, the total gauge widening at the load location does not exceed 5/8 of an inch, and when increasing the applied force of 0 to 4,000 pounds. 2, the gauge of the track measured with 4,000 pounds applied force does not exceed the allowable gauge prescribed in statute 213.53b of the section of the class track involved. Gauge widening in excess of 5/8 of an inch shall constitute the deviation from Class 1 standards. At location where compliance with cross-rail rail fastener requirements have been demonstrated with the use of the portable track loading fixture fully qualified statute 213.17, 213.7, the individual will retain the discretionary authority to prescribe additional remedial actions such as the placement of the speed restriction the individual deems necessary for the FRA inspector to determine the compliance with the cross-tie fastener requirements of the gauge restraints solely on the basis of the portable track loading fixture measurement. When cross ties are found to be severe, split with the plate of the cut, except that they are incapable of providing the adequate vertical support condition, they have to degrade with the point where the track surface condition approaching allowable limit of the class track. Inspectors should institute with concerning writing the defect and specification for the using 213 defective code 0109B2 cross ties effective distributed to support 39-foot segment of the track. Inspectors should record the track surface geometry condition as well as the contributing condition of the cross ties description column. When a functional portable track loading fixture is not available to fully qualified 213.7 of an individual during the scheduled important inspection under 213.233 of this part, the track owner must repair and replace the portable track loading fixture prior to the new inspection required under statute 213.233. The cross-tie rail fastener compliance will be based on solely on the requirements specified in the statute 213.109 and 213.127. All locations of the cross-tie rail fastener compliance question vertical loading track structure necessary to restore contact with lateral restraint components. The cross ties may be raised on unit and lateral restraint contact restored to the portable track loading fixture measurement that may be made. If the track owner fails to immediately restore the contact between the rail and the fastening system with a valid portable track loading fixture test can be performed, no action can effectively remove this location of the gauge resistant measurement standard. The inspectors determine the compliance based on the statute 239.109, 213.127. Likewise, the gauge has been installed with the valve of the portable track loading fixture to determine the gauge resistant cross ties fasteners action will affect the removal of the location. Gauge resistant measurement standard of the inspector will determine the compliance of based on the statute 213.109 and 213.127. 110N. The track owner shall maintain the record of the two most recent GRM inspections at the location meet the requirements specified in 213.241B, with the minimum record shall include the indicate the following: location and nature each of the first level exemptions, nature and date of the remedial action, if in any exemption identified with paragraph N1 of the section. Guidance. The paragraph requires the track owner to maintain a record of the two most gauge resistant measurement inspection location meeting the requirements specified in 213.241B with the required indication of the location and the nature of each first level exemption, nature and the date of the initiated remedial action, and if in any first level exemption is described in remedial action table paragraph L. or the record required under paragraph N is the official record of lateral restraint and needs to identify the bolus exemption level. How with remedial action is to be required to show only the first level exemption records may be maintained at the location to meet the requirements specified in 213-241B. 110. The inspection interval designated with the gauge resistant measurement system line segments shall be such as that the on segments annual tonnage exceeding 2 million gross tons, where the maximum operating speed of the passenger train exceeding 30 miles an hour. Gauge resistant measurement system inspection must be performed annually to an interval not exceeding 14 months. On line segments where annual tonnage of the 2 million gross tons is less than the maximum over operating speed passenger train does not exceed 30 miles an hour. Interval between the gauge resistant measurement system inspection does not 4 months. The paragraph O details the gauge resistant measurement inspection requirements illustrated in the following table. Traffic at annual tonnage exceeds 2 million gross tons, the passenger train exceeding speeds if applicable exceeding 30 miles an hour. Then, if annual tonnage is 20 miles, 2 million gross tons, and where the passenger trains, if it does not exceed 30 miles an hour, gauge resistant measurement system interval inspection must be performed annually at an interval not exceeding 14 months. Interval between gauge resistant measurement system inspection must not exceed 24 months. Or 110P, used in this section, gauge resistant measurement system means the track loading vehicle meeting the minimum design requirements specified in the section. Gauge widening projection means that the measured gauge widened with the difference between the load unload of the gauge supply of load projected with the reference load of 16 kIps, lateral force 33 kIps, vertical force. The load lateral vertical ratio means the snap numeral ratio lateral load applied within the point of the vertical load applied with the same point. Gauge resistant measurement system designed to specify the load lateral and vertical ratio between the 0.5 and 1.2. Load severity means the amount of the lateral load applied faster after the friction between the rail and tie overcome the applied gauge wide lateral load. Loaded track gauge LTG means the gauge measured with the gauge resistant measurement vehicle at a point no more than 12 inches lateral load application point. Portable track loading fixture PTLF means the portable track loading device capable of applying increasing lateral force of 0 to 44,000 pounds on a web base fillet out of each of the rails simultaneously. Projected load gauge PLG means the extrapolated value of load gauge circle is calculated, actuated, measured load deflection. Portable load projected load gauge 24 means the exploded value of loaded gauge under 24,000 pound lateral load and 33,000 pounds vertical load. Alright, unloaded track gauge means the gauge measured with the gauge resistant measurement system vehicle at a point no less than 10 feet at any lateral vertical load. Gauge is the paragraph prescribed list of definition terms essential to the implementation gauge resistant measurement technology. Well documented pattern and repeated with widespread deviation of requirements for this section. Track owner effectively terminate operation. Options afforded by this section. Affected track would then become subject to the requirements of statute 213-109, 213-127. Or 213-113 defective rails.